Okay, so we're moving on with linked lists. We've seen how to traverse a linked list and how to print from a linked list. You were able to do some exercises on how to loop, how to move from one node to the other, and things like that. Now we're going to see how to insert into a linked list. So we have to build our list before we can do anything with it. So we already talked about the node. Each node has a data and a pointer, and the node can be represented using a struct. We also talked about the head pointer, which always points to the first node. So right now, head is a pointer that will eventually point to a node, a data type node, so node star head. And right now it's pointing to null. So when a head points to null, that means our list is empty. There's nothing in it. Okay. So notice how the node struct is outside of main, so everybody can access it. If you pass it to functions, everybody should be able to access it. So there are three ways to insert into a linked list, just as there are ways to insert into an array. Um, there are ways to insert into a linked list. You insert at the end or at the beginning or anywhere in between. Now in arrays, you saw how that if you had to insert in between, you had to shift values, whereas in a linked list, there is no shifting involved, but you have to come up with an algorithm to figure out how to insert in between. So first, let's see how to insert at the end of the list, which is a little easier. So here is an existing linked list. Let's say we have head, and then we have a bunch of nodes that we've already added. Now, if you want to add to the end of the list, there is no way to get to the end other than starting from head and traversing the list one at a time. So we use a current pointer, start at head, and we say current next, current next, current next through a loop until we get to the last node when current is pointing to null. Then we know we're at the last node. Okay. So every time we have to do this, it is pretty cumbersome. So it would be nice if we could have a pointer always sitting at the last node, then we know where we need to add. So we could have that, and that's called a tail pointer. We call it the tail because it's to the very end, just like we have a head at the beginning of the list, we could have a tail pointing to the last node. So it looks like this. Here's a tail pointer pointing to the last node, and we make sure this tail pointer gets updated every time we add a new element, so it's always pointing to the last node. Okay, so let's see how to add at the end using the tail pointer. So now we have a head, node star head. That means head will eventually point to a data type node. Node star tail, tail will also eventually point to a node, which is what we want, both of them pointing to null. This is at the start of the list. Temp node is used to allocate memory for a new node every time. Okay, we need to allocate memory, then attach it to head. Notice this is not like an array where memory is already allocated. Every time we add a new node, memory gets allocated. So the process would be every time we add a new node, we allocate memory for the node. And who do we use? We use temp node to allocate that memory. And we add temp node to the end using head or tail or whatever. And then we release temp node to add the next node. Okay, so that's the process we're going to see. So here's how adding at end looks. Here's my temp node. I add temp node equals new node, allocate memory for node. Then we populate temp node data, put a number in there, temp node next is set to null. That's what we're doing here. Temp node data equals num. Maybe the user enters a number or we get it from wherever. And the temp node next is set to null. Always set this pointer to null until it points to the next node. Okay. So here we go. Head and tail are both pointing to null. That means we have an empty list. Okay. So we create a new node. Temp node equals new node, allocate memory, put data, put next to be equal to null, head equals temp node. So we need to always check if head is pointing to null, that means our list is empty. So we would have a condition. I haven't put the condition here, but we would normally check if not head, that means if head is pointing to null, then we want to take head and make it point to temp node. That's what we say here. Head equals temp node, which means the address here will go into head, and head will also be pointing to this node. Then, so that's how it looks. Then we want to take tail also and make it point to temp node. So tail equals temp node, because there's only one node. So both head and tail are going to be pointing to the same node. Then we take temp node and set it to null. We break that temp node away from that node because now head and tail are pointing to it. We don't need temp node to point to it. So temp node can be set to null. So the first node has been added. Now let's add the rest of the nodes. But before that, remember this is a special case. The special case being that the list was empty and there's only one node. Okay, so that's a special case. Once that case is done, we do it all over again for the next number. Here's how it looks. One node has been added, and this is our current list. Now we add temp node equals new node the same way. Allocate memory for temp node. There we go. New node, allocate memory. It's not pointing to null anymore. Now we add. Connect the new node to the end. So this is my current list. This is my temp node. Now we're going to add it. Here's the code. Tail next. This is tail next. This is tail. This is tail next. Equals temp node. So we take this address and put it into tail next. So tail next, which happens to be this node's pointer, is pointing to temp node. Then we take tail and make it point to temp node. This should not say 00 anymore. It should actually say 2020. Okay, so 2020 means this is pointing here. Tail is pointing to this. We want tail to point to the last node. So tail equals temp node. Temp node equals null. We break away temp node from there. So now our list looks like this. Head pointing to 2000, this pointer pointing to the next node, and tail pointing to the next node. So this is my last node, 2020. Okay, let's add a couple more. So here's my new list. This is one. This is the second node. Tail is pointing to the last node. I allocated memory for the next node that I want to add. Tail next equals temp node. Tail equals temp node. Temp node equals null. We break away temp node. Right? Over and over, the same process. Here's now my linked list with 3 elements in it. Okay? So here's the code. If you do that, again, if you put all that thing in a while loop, and we check, it's a sentinel controlled while loop. We check to see if we read the number from the user, let's say, and you check if it's not equal to -999, that means we want to add the number. So you temp node equals new node, allocate memory, put data into it, and you check. If it's a new list, which means if head is pointing to null, then we only have these 2 lines. Head equals temp node, tail equals temp node. We're done. We read the next number at the bottom and go back to the while loop. Once we've added one element, we're going to be here. And this is the code that we already saw. Tail next equals temp node. Tail equals temp node. So go back, look at the pictures. It will help you figure out what we are doing. Okay? And then you read the next number at the bottom, cin num, and then go back to the while loop. Okay, so this is kind of what you're going to do in your code. This is exactly what you're going to do. So use that slide for reference. We are also going to write a function to print our list. Notice we pass one parameter, which is my pointer, head pointer. All you need to do is pass the head pointer, and then the head is connected to a list, right, with pointers. So we can just traverse. We've talked about this. Current is a pointer of type node that points to head. And then we check. As long as current is pointing to something, you output the data, and you move to next. Current equals current next. When current gets to the last part, which would be null, the last pointer, then this would be null, and it will come out of the while loop. So you will find the code, the starter file in this folder. I'm going to show you all of that stuff right now real quick. You're going to write code in main to read numbers using a while loop, and then you're going to add using my slide a few slides ago that we saw where the code was. You're going to use this to help you write code there. And then we're going to write a print function to print the list, and then you test it. So here's how it looks. Here's the code. Notice I have a lot of things done here. The struct has been put in. There's a sentinel for you to use in your while loop. I have declared all the pointers, temp node, current, head, tail, everything has been declared. Num has been declared. This is the num you're going to read from the user. And here is where you need to write your code. Right there, the comment says your solution to read numbers, write the while loop, all that stuff goes here. So just read the number from the user, put in a while loop just like I have, add at tail. Once you're done adding and your while loop is done, that means when the user enters -999, we're going to stop reading, and then you're going to call the print list function. So the print list function is here at the bottom. I already wrote the prototype. All you have to do is write your function here. Notice my prototype is already at the top right there. Okay. So write the function, and the print list should call that function and it will print everything. If it prints everything and everything is good, then we come back here and I use a loop to go through and delete. Notice how we delete every single one of the pointer. We start with current equals head. Again, we traverse the list while current. We move current to next. We delete head. Then we set head to current and we delete every time. So, and there are a couple of different ways you can do it, but every time you have to move current to the next node, delete the previous node, then move current again, and so on and so forth. So we will worry about that next time. I've already written the code for that. So all you need to do is write these two things. Write the code to insert and write the print function. Okay? And then you can email me the CPP file for this.